This is a review for a final exam in college algebra, and we have 47 questions here. I'm going to work these pretty quickly, so if you have any questions, just let me know. Pause and rewind if you need to. And here we go. So for number one, I'm looking at the absolute value of this expression here, and I have a negative out front. So what I need to do is consider, just add negative 3 and 7, so I have negative absolute value of 4. Absolute value of 4 is 4, so I end up with negative 4. For number two, I want to determine the absolute value for x plus 2 for x greater than 7. So what I have to remember then, for x plus 2, if x is greater than 7, this is always going to be greater than 0. So because of that, I can simply drop the absolute value and end up with x plus 2. Now, if the question had said, what about for the absolute value of x plus 2 if x is less than, let's say, negative 5? Well, for anything less than negative 5, this expression is going to be negative. In that case, to drop the absolute value, I would need to multiply a negative 1. Okay, but since x plus 2 is always positive for things greater than 7, you just drop the absolute values. For number 3, I want to evaluate this expression here, and I'm given values for x, y, and z. So it's a matter of plugging it in. So I have 2 squared times negative 1 cubed plus 5 times the square root of 3 times 2 minus 2 times 1. Okay, doing a little arithmetic here. That's 4 times negative 1 cubed is negative 1 times itself 3 times. So end up with the negative 4. 5 times the absolute value of, that would be 6 minus 2, which is 4. The absolute value, I said absolute value means square root. The square root of 4 is 2. So here I end up with negative 4 plus 5 times 2, which is 10, end up with 6. For number 4, I want to simplify this expression, and what I recommend is to write everything in the numerator, because we're using a property here that says if I have x to the negative n power, that's the same as 1 over x to the n power, or 1 over x to the n. Those are all the same thing. So what that means then is that I can bring everything into the numerator, which I think is the easiest way to do this. So you have 9x squared, y the negative 5th, z the negative 11. Now bringing this stuff up into the numerator, I have 2 to the negative 1 power, x to the negative 8 power, and y to, it was the negative 7, but bringing it up into the numerator makes it a positive 7. So from there I can add like terms, or multiply like terms is what I mean, but I said add because remember, if you have x to the m times x to the n, that's m plus n power for x. Okay, so these are two properties of exponents we're using here. So then multiplying all this out, let's see, I end up with a 9. And x's, I have x squared times x to the negative 8. That gives me x to the negative 6th. I have y to the negative 5th times y to the 7th. That's y squared. I have z to the negative 11th, and that's all I have for z. So there's that, and then I have 2 to the negative 1. So now, keeping all the positive exponents in the numerator and let's push all the negative exponents down in the denominator. That gives me a 2 x to the 6th, z to the 11th in the denominator. That's exactly what they have here. Number 5, I want to simplify this algebraic expression, and so all this is really wanting us to do is to combine our like terms, and the only trick would be to distribute this negative across. So in doing that, I see for my constant term, well, let's go with highest powers of y. So starting out, I have a positive 3 y to the 4th. I don't have any y cubes, but then I have a negative 8 y squared. For y to the first power, there's plus 5 and one more. That gives me a plus 6y. And then I have a negative 2 minus 1 ends up with negative 3. You see, once I do that, I get this answer. So they're just making sure we can understand how to combine like terms and distribute negatives. Number 6, though, we want to multiply these two expressions. And this time I'm having to use the FOIL method, or a version of the FOIL method, where I'm distributing the a across, distributing the 5b across, and then adding my like terms. So when I distribute the a across, I have 5a squared minus 7a squared times b, right? Because that was negative 7ab times a. So that gives me a negative 7a squared b. And then I have a plus 2ab. Distributing the 5b, I have 5b times 5a, which would be 25ab. 5b times negative 7ab gives me negative 35ab squared. And then I have a plus 10b squared. Okay, now combining my like terms, let's see. The only like terms I really have are these two in the middle, right? There's only one a squared term. There's no a squared b terms other than this one, and etc. So I just combine those. So that gives me a 5a squared minus 7a squared b. 2ab plus 25ab results in a 27ab. Then I have negative 35ab squared and a 10b squared, and there's our answer. Pretty straightforward. Number 7, this time I want to factor, and what I have to remember here, and so notice that I have a binomial, so there's only a few binomials that we have tricks for. One of them is a squared minus b squared. The factors is a minus b times a plus b. Alright, so here what I recognize is that the 16 x squared is the same as 4x squared, and y to the 6 is the same as y cubed squared. And how did I know that? That introduces another exponent property that says if I have x to the m raised to the n, that's the same as x to the mn power. That's multiplying powers. So that 6th power was the same as the cubed squared, okay, which is what we wanted. The reason I want that now is because 4x can serve as a, and y cubed can serve as b into my formula. So that means I have a minus b, which is 4x minus y cubed, times a plus b, which is 4x plus y cubed. And there's our answer. Okay, and we call that difference of squares. Number 8 is a simple factoring problem. I just need to figure out, can I think of two things to multiply to give me negative 12 and add to give me negative 1? And you may have to think a little bit, but how about negative 4 and positive 3? Those multiply to give me negative 12 and add to give me negative 1. That's exactly correct. Number 9, this time I can't factor that way. The first thing you should always try is factor by greatest common factor, but that won't work here either. So we're going to move on to a technique called grouping. And grouping says I take the first two terms and put them together. I take the next two terms and put them together. So let me put in a plus there so I don't accidentally mess up the distribution of a negative. And now I take my first two and factor out a common factor. And notice I can take out an x out of those first two things. So that would be n plus 3m. Out of the second two, it looks like I can take out a negative 2 and a y. So maybe a minus 2y. If I do that, the first term becomes an n. That's all that's left. The second term becomes a plus 3m. And now notice I have two terms, this one and this one. They're terms, but they have a common factor of n plus 3m. So now I'm allowed to factor out my common factor of n plus 3m. When I take it out of the first term, I'm left with an x, and now the second term, I'm just left with a negative 2y. And now look, it's factored. And that's exactly what we have here. Just notice that n plus 3m is the same as 3m plus n. Those are the same thing. All right, number 10. This time we're going to factor, this is another binomial, but this looks like the sum of cubes. So I have to remember, okay, if I have an a cubed plus b cubed situation, that factors as a plus b, a squared minus ab plus b squared. And let me go ahead and give you the difference of cubes as well. It looks very similar. You say a minus b times a squared plus ab plus b squared. Okay, so those are your two special factoring techniques dealing with cubes. In this case, I have x cubed, and remember that 8 is the same as 2 cubed, right? So in this case, I have a is x and b is 2. So that means this thing factors then, according to my formula here, as x plus 2 times x squared minus 2x plus 2 squared, which is 4. That's exactly the answer we have. Number 11, says factor 7y to the negative 1 plus 5y to the negative fourth. Now I'll give you a hint. Anytime you see these negative exponents like this, more than likely this is a factor by greatest common factor question. So in greatest common factor, you want to take out the least power. And so since these are negatives, that means that both of these guys, I want to take out a y to the negative fourth power. That was the least power of y in each one. Now when I do that, my first term I'm left with 7y to, let's think about it for a second, fill in the blank power, plus the second term, I took out all the y's, so I'm just left with a 5. And now I need to think, okay, when I distribute this y back in, when I distribute the y times the 7y to some power, I need to get y to the negative 1. Remember, when I multiply those together, I have to add the exponent. So I'm thinking in my head, negative 4 plus something equals negative 1, and we know that would be 3. So that's the solution here. That fill in the blank for the exponent is y cubed. And you can always test to make sure you got that right by distributing y to the negative fourth back in. Alright, we're going to move on to some complex numbers. So number 12, I want to evaluate the square root of negative 49. And remember, the trick with these is that the square root of negative 1 is the value I. And so another thing you're going to need to know is that I squared is the square root of negative 1 squared, which results in a negative 1. That's not a real number because normally anything squared is positive. But now we can introduce this concept, and it's very useful. So to evaluate the square root of negative 49, the negative I know is going to come out as an I, so then I'm left with the square root of 49, which we see is just going to be 7i. Now 13, we're going to do some arithmetic with complex numbers. We're just going to add 2. Adding complex numbers is pretty easy. We just add the 2 real parts, so that's the 7 and the 3. And then we add the 2 what we call the imaginary parts. This is the negative 2i and the 5i. So 7 plus 3 is 10. Notice that's here. And negative 2i plus 5i is 3i. So we just combine our like terms, and that's exactly what we get. Number 14, this time I want to multiply two complex numbers together. And to do that, I'm going to have to use FOIL method. So I'm going to FOIL them out like this, just like we would an algebraic expression. And first I have the first term, so that's 7 times 3. That gives me 21. Outside gives me 7 times 5i, 35i. Inside I have negative 2i times 3, that's negative 6i. And then lastly I have negative 10i squared. Now remember, I squared is the same thing as negative 1. So this guy actually becomes a real number again, because that's negative 10 times negative 1, which ends up becoming a positive 10. So now when I combine my like terms, I have a 21 and a 10, which would be 31, and I have a 35i minus 6i, which ends up with 29i. So there we have it, 31 plus 29i. 15, here I want to simplify this through division. And the way I do this is I multiply by what we call the complex conjugate. And what that looks like is 4 plus I. So you take the denominator and you multiply it by its conjugate, meaning you make the middle the opposite sign. Okay, now the reason this is useful is because notice when I distribute in the numerator, I just have something pretty simple. I have 2 times 4, which is 8, plus 2i. That's 2 times the numerator. And the denominator, though, when I FOIL this, look, I get 16 plus 4i minus 4i minus I squared. Now remember, I squared again is negative 1. So this is 8 plus 2i over the complex terms cancel out. This guy is negative 1, so I have minus a negative 1. So that becomes 17. And that's what we have here. And multiplying by the conjugate will always get you back into the real numbers. That's why this technique is useful. Number 16, this time we're just solving a linear equation. So we just need to make sure we just do our algebra correctly. I'm going to distribute the negative and then multiply the 2. And now I need to get all my x's on one side and everything else on the other. So I'm going to move my x's onto the left-hand side. Let me say the right-hand side. So I add x to both sides, it gives me 3x. Okay, over here I bring the 3 over to, I'm bringing this 3 over to the left hand side. So that would be 6 plus 1 gives me 7. So then x equals 7/3. Divide both sides by 3 to get 7/3. For 17, it's a similar thing, so this time we have an absolute value. So what I'm going to do first of all is isolate the absolute value expression. So subtract 4 from both sides to get absolute value of 2x minus 7 equals 1. Now to drop the absolute value, all I have to do is consider the two cases. 2x minus 7 might be 1, and 2x minus 7 might be negative 1. Because look, if I take the absolute value of those sides here, I end up with the value of 2x minus 7 equals 1, which is what we wanted. Okay, so now solving these two linear equations, first of all I have 2x then equals 8, or x equals 4. For the second one I have 2x equals 6, so x equals 3. And that's the two answers I have here. 18 now, we have a linear inequality, and so you solve that just like you would a linear equation. I'm going to distribute the two, and I need to get x by itself. So what I'm going to do is I'm going to subtract 2x from both sides. So I end up with a negative 3x on the right. I'm going to subtract 7 from both sides, so I end up with a negative 9 on the left. So then when I divide both sides by negative 3, I would have x is greater than 3, but this is actually incorrect. So remember, when you divide by a negative, you have to flip your signs. Okay, so we had a flip because we divided by a negative here. So now looking at a number line, here I have 3. 3 is not included, and according to this, x is less than 3. So I'm talking about this part of the number line, which starts at negative infinity and ends up at 3, so then I have that as my solution. Number 19, here I want to solve the quadratic equation x squared minus x equals 2. Quadratic equations work differently from linear equations. This time I want to get 0 on a side, and so I move everything over. And for this, the first thing you should try is factoring. And in factoring, I think of two things and multiply to give me negative 2, add to give me negative 1. How about x minus 2 and x plus 1? I believe that'll do it. Multiply to give me negative 2, add to give me negative 1. So then I have the two linear equations, x minus 2 equals 0, which means x equals 2, and x plus 1 equals 0, which means x equals negative 1, and there are my two solutions. This only works if you set the equation equal to 0, by the way. Number 20, though, we don't need to do that because of the way it's written. I have a perfect square on both sides of this equation, so I'm going to take the square root of both sides, and when I physically write in square root, like square root of 49, when I wrote that in myself, I need to consider plus or minus. Now the square root of 2x minus 1 quantity squared is just 2x minus 1, and we know the square root of 49 is 7, so I have 2x minus 1 equals plus or minus 7, which means I have two equations. The first one is 2x minus 1 equals 7. The second one is 2x minus 1 equals negative 7. So the first one, I end up with 2x equals 8, or x equals 4. And the second one, I end up with 2x equals negative 6, or x equals negative 3. And there are my two solutions. 21, we have a quadratic equation that when I set everything equal to 0, I get x squared minus 6x plus 16 equal to 0. And I've tried factoring, so I've tried to think of two things to multiply to give me 16 and add to give me negative 6. And after a while, you realize that's not possible. So I need to move on to something more sophisticated. I'm going to move on to the quadratic formula, which says this. If you have ax squared plus bx plus c equal to 0, then your solutions are going to look like negative b plus or minus the square root b squared minus 4ac all over 2a. So in this case, what that means then is x equals negative b, which is 6, plus or minus the square root of b squared, which is 36, minus 4 times 1 times 16 all over 2a, or 2 times 1. So then underneath the radical I have 36 minus 64, so that results in 6 plus or minus the square root of a negative 28 all over 2. Okay, so simplifying negative 28 is the real question here. I know that the negative becomes an I, And I know that this is 4 times 7, not 47, 4 times 7. And I know the square root of 4 is 2, so I end up with 6 plus or minus 2i root 7 over 2. Since there is a 2 in all three terms here, I can cancel out a 2, but only because it's in all three terms. And I'll end up with 3 plus or minus 7, square root of 7i. Okay, so that means in our answer key here, we actually need a square root, but then there we have it. Okay, so there needs to be a square root of 7 there. Alright, now number 22, we have this weird equation. It says solve this x squared plus 2 quantity squared minus, okay, we have some stuff. It looks real complicated, but if you notice, I have something squared minus 7 times that something plus 12. It looks kind of like this. You have an empty box squared minus 7 times that empty box plus 12 equals 0. That almost looks like a quadratic equation. And so actually we're going to treat it like that in this way. I'm going to let y be x squared plus 2. Okay, that's the thing, that's the empty box here. And so in doing that, my equation then becomes y squared minus 7y plus 12 equals 0. Okay, that's a quadratic equation. I'm going to try to factor it. So I need to think of two things. To multiply to give me 12, add to give me negative 7. How about negative 3 and negative 4? So in doing that, then I end up with y equals 3 and y equals 4. But remember, we don't really care about y. Y is just the middleman here. We want to get x. So replacing now back with our substitution of what x is, I have x squared plus 2 equals 3 and x squared plus 2 equals 4. So in the first quadratic, that gives me x squared equals 1, or taking the square root of both sides. Remember, when I take the square root myself, I need plus or minus. So that becomes plus or minus 1. And the second one, I have x squared equals 2. So when I take the square root of both sides, I need to take plus or minus square root of 2. So there are my four answers, plus or minus 1 and plus or minus root 2. And I really think that this substitution in the middle kind of helps clarify what we're doing. 23. Okay, this time I have a cubic that looks kind of bizarre. So what I'm going to do is I'm going to try factor by grouping. I can't take out a greatest common factor. That would be your first technique to try. So I'm going to move on to grouping, and so I'm going to group my first two terms together and my second two terms together and just hope for the best. Okay, so my first two terms, I think I can take out an x squared. When I do that, I'm left with an x minus 1. Out of the next two terms, it looks like I can take out a 4. In doing that, I can take out an x minus 1 as well. And that's actually good news for us, because now I have two terms that have a common factor of x minus 1. So I take out the x minus 1 factor, and out of the first term, I'm just left with an x squared, and out of the second one, I'm left with a 4 equals 0. So see, factor by grouping actually worked for us here. I can factor it, and I end up with the equations x minus 1 equals 0, which gives me x equals 1, and I end up with x squared plus 4 equals 0, which would be x squared equals negative 4, or x equals plus or minus the square root of negative 4, which we know is plus or minus 2i. So there are my three solutions, 1 and plus or minus 2i. I'm going to work the rest of this in the next video. I hope this makes sense so far. If you have any questions, let me know. I'll be glad to help. Thanks for watching.